Cover yourself up. Wear some good gloves, a hat, keep clean lenses in your welding hood, and always wear safety glasses. Before you light the rod, get comfortable. Scratch to light the arc. Bring the rod back and start the puddle. Maintain a uniform arc gap with the amperage set high enough to let the puddle spread out. The molten metal follows the heat. Make sure you're filling in along the edges to avoid undercut. Add a little extra metal to the puddle before pulling out back over the weld. You should always examine the finished weld bead for any defects, but really, you need to see the weld as it's going in. This is a totally manual process. You have to control the heat and filler metal during the weld by watching and understanding the molten puddle. Look past the rod and the light, focusing directly on the molten pool. Watch the edges and the weld buildup, constantly analyzing how it's flowing out and how fluid it is, making slight adjustments when necessary. The amperage setting, which regulates the amount of current flowing through the rod, is the main control of the heat available to the weld. When the amperage is set too low, the puddle only forms under the rod. Increasing the amperage generates enough heat to form a molten pool. Along with starting to get penetration, this is where you begin to have control of the edges of the puddle and the weld buildup. There isn't an exact amperage setting here. In fact, this is one of those things that welders see differently. Also, as the metal thickness or weld position changes, the amount of heat required will be different. Watch the puddle. You're looking for it to flow out to the sides of the rod. When the amperage is increased more, the molten pool penetrates deeper and spreads. Eventually, the filler metal becomes so fluid and agitated you can no longer control it. Experiment with the amperage setting. For good penetration and smoother welds, you want the amperage set as high as you can while keeping the molten metal from becoming too fluid to handle. Because of the characteristics of the flux coating, the puddle will look different depending on the type of rod you're using. The entire puddle is visible with 6010 or 6011. Slag covers the top rim of 6013, but the molten metal is still visible on the sides, and the puddle should move easily with the rod. With 7018, slag covers the entire puddle, but you still want to see it flowing out to the sides, with the slag solidifying back from the rod. During the weld, the filler metal is actually solidifying underneath while the slag stays molten. Regardless of which rod you use, the amperage only provides the heat. The rod angle determines how fast the metal will heat up. When the rod is held more perpendicular, the molten pool forms and spreads quickly, allowing a faster travel speed to limit penetration on thinner metals, deposit less metal for a smaller weld, or flatten the bead in a bevel. As the rod is angled, some of the heat is taken off the metal. A slower travel speed can be used to build up a crowned weld bead. If the rod is angled too much, the metal won't get hot enough. The molten pool will narrow, the bead will stack up, and you'll lose control of the edges of the puddle. On most weld joints with a good fit up, you want to maintain a consistent rod angle to produce a uniform weld bead. In some situations, though, you may need to vary the rod angle during the weld. To fill a gap in a weld joint, the rod can be angled more, slowing down to deposit more metal, keeping the build-up uniform, then angled back up to finish the weld. Controlling the rod angle takes a little practice, but you need to stay loose and relax. Whether you're holding the rod up to flatten the bead or angling it to build up weld, you want to travel at a speed that keeps the molten puddle the same size. Watch the puddle. If the travel speed is too fast, the metal doesn't have time to melt, so the puddle narrows. If the travel is too slow, the metal gets hotter and the puddle spreads. Depending on the rod, the filler metal may flatten out or stack up and roll. Always maintain the size of the puddle with the travel speed. Last is the arc gap, which is the distance from the tip of the rod to the metal. Shielded metal arc welding machines use a constant current power source. The amperage is set with the voltage varying to maintain the arc. You want to avoid jamming the rod right down against the metal or long arcing too far, but you can use slight variations in the arc gap to help control the heat and shape the weld. This is difficult to measure, but a medium arc length is used to build up weld. Shortening the arc reduces the heat, cooling down the weld puddle. Try using a shorter arc gap on vertical up with 7018 when you want to build up more weld. Slightly lengthening the arc causes the heat to increase, spreading the puddle out, and is used with a more perpendicular rod angle for making smaller beads or flattening the weld on heavier metal. It is important to be consistent though. Varying the arc gap during the weld changes the heat, making it difficult to maintain a uniform weld puddle. When you start looking at all the aspects of running a weld bead, there are many possibilities. That's why everybody welds a little different. Practice and experiment, trying to make that puddle do what you want it to do. Watch other welders if you get the chance, but in the end, you need to see the weld puddle at the end of your rod and develop a style that works for you.